Hello, this is Professor Fisher, and now we're going into Chapter 5, the integumentary system, basically looking at the skin, which is the largest organ in the body, and discussing the properties of that organ system. Just some anatomy and some statistics on the skin. Skin is 10 to 15% of your total body weight. So for those of you all who are trying to lose weight, it is uh, you can't lose your skin. That's one thing that you actually absolutely have to have. Contrary to popular belief, you also do need some fat. We talked about that earlier, just so you know. It covers the outside of the body, but it's more than that. And because it also not only protects your body, but it has a lot of functions, for instance, sweating, cooling your body temperature, or shivering, raising your body temperature. So there's a lot of things that are involved with the skin. Uh, you can think probably, if you look at someone's skin, you can tell certain things. I've done a lot of work with people who are struggling with alcohol and drug abuse, and you'd be surprised when you see someone who is in the throes of addiction, what their skin looks like. You can tell they're sick, and then just a couple months later, having stopped using the drug, whatever it might be, their skin looks so much better. Their skin clears up, and they just look healthier. And so we can actually use the skin as a diagnostic tool to let us know someone's health. Uh, Even babies, we know with the whole thing with jaundice, if you've ever heard of that. And we'll talk about different issues as we discuss this chapter. This We call the skin, it is an organ, but we also refer to it, you'll hear it referred to as the cutaneous membrane. Um, and we talked about membranes a little bit in the chapter on tissues. And so we have two main components. Epidermis is the superficial layer. Superficial means basically on top. So that's what you see when you look at your skin. You're seeing the epidermis, keratinized. That means keratin is a protein. Keratinized stratified squamous epithelium. Stratified, multiple layers. Squamous meaning flat shaped epithelium, which is resting on a basement membrane. And then you have deep to that, which is the dermis, deep to the epidermis. And it is loose connective and dense connective tissue. Loose, connective, dense, irregular. Right. So we're going to talk about that. And that's basically what makes up your skin. Beneath that, you have what we call subcutaneous fat, which is not considered part of your skin, but it is very important to the skin. This is the basic structure of skin. You see the epidermis, that thin layer on top. Remember, epidermis is epithelial tissue, therefore it is avascular. You see the dermis layer, and then you see the hypodermis or subcutaneous fat. Subcutaneous, meaning below the cutaneous membrane, or otherwise known as the hypodermis. Not part of skin, but that's usually where you have, remember, fat is another connective tissue below that. Right? We see the neurons here in the dermis layer. We see hair. We see sweat glands. Right? All of this is part of your skin. Right? Like we mentioned before, skin has accessory structures. Remember, skin has a lot of functions, not just protection. We have sweat glands, sebaceous glands, where we'll talk about the oil on the skin, hair and nails. We also have sensory receptors, erector pili muscles, Remember that the epidermis is avascular. I noted that again here, very important. So relies on diffusion, oxygen and nutrients. So it must get its nutrients from the connective tissue, the dermis layer, right? So that limits the epidermal thickness. Notice how the epidermis is not as thick as the dermis because the epidermis it's avascular, right? So it can only get so thick because it has to stay close to the dermis. About 50% of the epidermal cells are too far from the blood supply to sustain life, and therefore the top layers of your skin are actually considered dead. We also have the hypodermis, like I said, otherwise known as subcutaneous fat, deep to the dermis. It's not part of the skin, but it helps anchor the skin to your muscle and your bones, which are, if we go deeper, we'll get to those. In general, the structure is epidermis, dermis, subcutaneous fat, muscle, and then bone. So if I was to go into my arm, with a needle, it would go through the epidermis, dermis, subcutaneous fat, and then muscle, and then to my bone. That's why if you've done, or if you've known anybody that's had to do a bone marrow transplant or something with, where they had to take a sample of bone marrow, you have to get all the way in. So you have to go through the epidermis, the dermis, the subcutaneous, the muscle, and then get into the bone, which also is, a very strong structure. So you're going really deep. When I had the coronavirus vaccine, it's intramuscular, all right? So they want to go epidermis, dermis, subcutaneous, muscle, and stop there and release the vaccine into the muscle, right? So that's intramuscular. So you're going to need to know the layers that are involved with the body, right? So the hypodermis or subcutaneous fat is just deep, just below the dermis, helps anchor the skin to the rest of your body. It's made of loose connective and adipose tissues, right? Adipose fat, loose connective and adipose tissues, and also has an abundant blood supply. All right, let's go through the functions of the integumentary system. Number one is protection, which makes a lot of sense. All right, your skin is a barrier. It covers your body, protects you from the environment. Right, those stratified squamous keratinized epithelial cells provide a flexible, durable surface. Touch your skin, you can hit it. Things don't get through very easily. It also blocks small things like bacteria, viruses. Notice they said with the coronavirus, the problem wasn't the coronavirus getting through your skin. It was getting on your skin and then you putting your fingers in your nose or your mouth. And that's the way it entered the body, because normally bacteria, viruses, things like that, there are some that can get through skin, but normally they do not get through skin. Okay, so that's important to note. It is a barrier not only protecting us from mechanical trauma like bumping into the wall or something, but also protecting us from microorganisms. And there is some immune system responses to the skin that we will talk about. The sebaceous glands also make your skin slightly acidic. We'll talk about those. You saw those in the diagram, the sebaceous glands. And so that inhibits the growth of pathogens. Also, they always say, wash your hands. We wash ourselves, we take showers, baths, whatever, which also removes pathogens and things like that from the surface of our skin. We are protected from UV light, especially those of us who have skin that's more pigmented. That UV light could potentially damage other parts of our skin, right? And remember, if some of you may remember, if you jump into the water, you don't drown. like that water, like if I jumped in a pool, all the water doesn't just seep in through my skin. Why is that? It's because it's waterproof. We have the ability of sensation in regards to skin. Those nerve endings, which are in the dermis layer of your skin, um, help with sensation. We can sense the world around us. I would go a lot further with this, but for the purposes of this class, um, let's just say it's nice. The touch is an amazing thing. I love massages, because I exercise, and I was an athlete in college many years ago, and I continue to exercise. Muscles get sore. And one of the things that I do love is getting a professional deep tissue massage. Um, I wish my wife was a professional masseuse, but she is not, and so I have to pay for it. But it's wonderful what you can do. And how the body can respond. We also have receptors that sense heat, cold. If you go outside right away, your skin can tell you, even if your eyes are closed, your skin can tell you that it's cold outside. It sends a signal. And we'll talk about that connection between the nervous system and the integumentary system. Thermal regulation, your body. You notice if you go into a place that's cold, you can do things to warm yourself up. Your skin can do things even without you thinking, purposefully consciously doing something. You may notice that first you're cold, and then maybe 30 minutes later you're not as cold. Your skin, we can redirect the blood supply, the blood flow, so that not as much blood goes towards the surface of your skin, and therefore helping keep your body warm. Or the reverse can happen. If you go someplace and you're hot, more blood can go towards the surface of your skin, and therefore more heat from the inside of your body can be released to the outside and cool you off. Or sweating, that's another way you can cool off. All right. And we'll talk about that in more detail. Um, when temperatures rise above normal, like I just mentioned, you have this control center actually in the hypothalamus, which acts as your body's thermostat. The control center can stimulate sweating, also vasodilation. Dermal blood vessels widen, they dilate, increase blood flow. Uh, and when body temperature returns to normal, you get this negative feedback mechanism, and things go back to normal. Right? And the same thing can go in reverse, and I mentioned that. When the body temperature drops, your hypothalamus acts, and we're going to talk about the hypothalamus when we talk about the endocrine, the brain, and also the endocrine system, the nervous system and the endocrine system. When you're cold, the blood vessels vasoconstrict, reducing blood flow, so less blood flows to the surface of your skin. More blood stays towards the inside of your body where it's warm, conserve heat, and you do that until your temperature goes back to normal. So this is all, this is your nervous system, your circulatory system, all working in conjunction with your integumentary system. And that's a diagram of that. We also have excretion. Remember, excretion is a sign that something is alive. First of all, we as human organisms are absolutely alive. We are animate beings, and therefore we have the ability to excrete, right? So there are some waste products that are excreted through your skin. Sweat is actually considered a waste product. Has a little smell to it, as you may have noticed. All right, so there is some excretion. Skin also plays a role in vitamin D synthesis. Modified cholesterol molecule is the precursor converted to cholecalciferol, and by exposure of the epidermis to UV radiation. Is why they say it's important for you to get sunlight. It's released into the blood, modified by the liver. We're going to talk about that when we go into the digestive system. Then the kidneys, which is the urinary system, and then that forms calcitriol, which is the active form of vitamin D, which that is required for the calcium ion absorption. You need you need this to be able to absorb calcium in your body, right? Calcium is very important. We're going to talk about that in the nervous system and also the muscular system.